Hey guys, Mike here from Arnold Tutoring, and we're going to talk about continuity in this video. First thing, the general definition of continuity is up here written in blue. It says that in order for a function to be continuous at x equals a, so, a function can be continuous at a particular x value and then not continuous at another x value. We're always going to focus on one particular one that the question gives us or that the graph gives us. So at any value a, it is continuous if these two criteria are met. The limit as x approaches a of f of x equals L and f of a equals L. What is the difference between these? Remember that the limit as we're approaching a, that means that we're just getting really, really close to some x value a. We don't actually care what the y value is at x equals a. We just want to know what the y value is getting really close to as x approaches a. Versus this piece of it is saying, what is the actual y value at x equals a? So it's the difference between the limit as we approach an x value and the actual x value. This can be taken an extra layer deep. Remember from the last video on basic limits, this can only happen. In other words, the limit can only exist if the limit is the same from the left, which is when we put that little minus there on a, and from the right. So let's look at two examples, one where it's continuous and one where it's discontinuous. Taking a step back even from these two rules, that the limit has to equal the value, the easiest way to tell if something is continuous at an x value is, can you draw the function through that x value without lifting your pen? If the answer is yes, it's continuous. If you have to lift your pen, it's discontinuous at that point. Let's look at this first example, the red function. So the question is it continuous at x equals 3? Well, we know right off the bat that it's a no. And the reason we know it's discontinuous is because as I draw this red function and my x value gets closer and closer to 3, I have to lift my pen because this open hole means it's undefined there. We actually have to jump up to fill in this point here, 3, 4. So because I have to lift my pen to go through 3, it is not continuous. But let's prove it using this algebraic definition. So first let's say, what's the limit as x approaches 3 of f of x? Remember, limit just means as x gets really close to 3, what's y getting really close to? Well, we can see that as I trace that in green, the y value is getting really close to 2. How about from the right? Same thing, right? It's following the same pattern. The y value is getting really, really close to 2. So we'll call this 2. Now, what is f of 3? That's this second part of the definition. Well, f of 3 is the actual value at 3. So we don't care what it's getting closer to as we approach 3. We actually care at 3, and that's this filled in point here. So f of 3 actually equals 4. And that is the reason that this is discontinuous. So because the limit as x approaches 3 of f of x is unequal to f of 3, unequal to the actual value, it's discontinuous. Okay, so that should be a pretty good visual definition of why this is discontinuous. But again, you can always go back to the basics when you have a graph and say, oh, I had to lift my pen, so it's discontinuous. Let's take a look at this one. Again, we're going to do it at x equals 3. So is it continuous at x equals 3? Well, we can see that you don't have to lift your pen to draw it through 3, right? I'll trace it right here in orange. Not lifting my pen. Yeah, the function looks like it changes a little bit at 3, but it's keeping that same point. So we know it's going to be continuous. Let's prove it algebraically. First piece is the limit as x approaches 3 of f of x. What does this equal? Well, from the right, I'm approaching 3 from the right, it looks like it's getting really close to 1. From the left, it looks like the y value is getting really close to 1, so we'll call this 1. What about f of 3? That's the second piece. Well, we can see that there's an actual point value there. There's no hole, it doesn't jump or anything. So the actual y value at 3 is 1. And the fact that these are the same, if the limit as x approaches 3 of f of x equals the actual value at 3, it's continuous at 3. Continuous at x equals 3. Okay, so this is the formal definition up here. We need the limit, in other words, the y value as we approach a certain x value, to equal the y value at that x value. That's very important to get the distinction between these two parts. And don't forget to break down the actual limit into the left side and the right side. Other than that, if you can lift your pen, if you have to lift your pen, it's discontinuous. If you can draw straight through the point, it's continuous. Hopefully that was helpful. Feel free to send us more questions at info@arnoldtutoring.com. Thanks.